the final day of notes for 6.3, number 15. They ask us to use a binomial theorem to find an answer. So I got to tell you what the binomial theorem is before you can use it. The binomial theorem is a formula that you can use to find the coefficient of a term instead of the Pascal's triangle. So that's what you can use binomial theorem, which came out of the Pascal's triangle. They just shrunk it down to a little formula so that you can find a coefficient of any term. And it comes from that probability formula. Okay, let's say I'm gonna find the 8 choose 6 or something like that, okay? I want to know how many ways I can choose 6 objects out of the 8 that are sitting there. The order doesn't matter. Okay. You have to take the factorial of your, remember n equals 8. That's your power. And then here, it's your 6 objects you're choosing from. But it's the 7th term because you start at choosing 0. So if you choose 0, that's your first term. If you choose 1, that's your second term. Choose 2, that's your 8th term. Choose 3, la 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 la. Then you can find the coefficient by taking 8 factorial. That means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what factorial means. And then I take the difference between my power and my r. It's factorial, and then times my r factorial. Okay. So right now it's a lot of letters, right? And I wonder where it came from. Well, instead of building our little triangle, they just plug and chug in this formula. So 8 factorial over 8 minus 6 is 2 factorial, and 6 factorial. I'll show you what, if you've never seen, have you guys seen factorial before? That symbol there with the exclamation point, not exclamation, it's hard to say. Okay, good, you're going to learn something new today. Okay, this means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what 8 factorial means. I don't know if our calculator has a factorial button or not. I don't see one. Okay, over 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. That's 6 factorial. See how these all cancel? So my 7th term with the power of 8 is 8 times 7 divided by 2. Okay. So I'm going to count to my 7th term on my Pascal's triangle to see if the coefficient's 28. Ready? Set. I'm going to show you, okay? Here's my power of 8, and I got to go to the 7th term. First term, second term, third term, fourth term, fifth term, sixth term. 7th term, look, it's 28. Crazy. It works. So you're saying, oh, I don't need my Pascal's triangle anymore. Yeah. Don't forget where you came from. Just saying. If I gave you just this, it wouldn't make much sense. You just, say, oh, that's nice, whatever that means, right? But now you know how they were created. This is a shortcut to that creation. I don't know who found it for sure, Newton or somebody. Okay, here's an even more, I want to say, streamlined way to get this number. There is a button on your calculator that will let you do this operation. So I want to show you how to enter it. You put in your power 8. You hit the PRB button. Anybody use that button before? Somebody showed this to me last year that was like, came out of honors geometry and they'd seen it before. But just depending on your experience and your teacher and if they gave you this information and if you got to probability and la, 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 la. Anybody use that button before? PRB? Oh, okay. I'll show you where it is. It's right there. So I put in my 8, because that's my power. I hit my probability button, and I got 2 choices. I can find a permutation. That means order matters. Oh, there's a factorial button. Yay. Or I could choose a combination. So I'm going to go down to choose to choice 2. So choose number 2, which says NCR, and then you put in your R. So us would be 6. So I put 8, then I choose the second function, and then I put a 6 in. And there's the 28. So you don't have to do all this hard work, but that's what your calculator does for you. It enters this formula in. And you're going, well, what good does that do? Well, now you have your coefficient when you're going to find a certain term of a polynomial without multiplying it out 8 times. So that's the power of the formula. So 15, my 15 from my homework examples, which hopefully or not is different than yours. It helps it's a little different, so you can practice. Mine 15 says, find the 4th term of x minus 1 to the 6th. So you get your pieces and parts. You use your little combination button on your calculator, or you can count over on your Pascal's triangle, whatever you want to do. 4 terms means R is 3. That's what we use in the formula. That's because we start counting at 0. My N is 6. So in my calculator, I'm going to push 6, PRB, choose N, NCR, and then I'm going to put 3. So 6 PRB, go to NCR and put 3. And I get my coefficient out for 20. So this is how you find the coefficient without the Pascal triangles template. So my fourth term with these two terms start with a 20. Now I take my first term. If I'm 4 down the road, I had 6 to begin with, and I moved over 3, 0, 1, 2, 3. So this is n minus r up here. Then I take my second term to just r. So how do I get the coefficients? I know that it moves. Let's say if I was just doing a plus b to the 6th, it goes 20 a to the n minus r and b to the r. So I take the n minus r for my first term's power and just r for my second term's power, because my first term's getting smaller and my second term's getting bigger, depending on how far down the road I go. So I have to do the simplify. -1 times -1 times -1 is -1 times 20, -20, x to the 3rd. That's the fourth term. And you can multiply this out 6 times if you feel in the need. Then you can read what the fourth term says. That takes a lot longer. So we can use this pattern for 16, 17, and 18. Just what do they tell us to do? Are you ready? This is the final result. We found the fourth term of this expanded binomial. I'm on 164. I have to jump over to 170, 180. No, 170. Yeah, 180. Okay. It'll go faster now. You've heard all the background. Okay, so I'm going to jump to page 180 for me. This is 178. It'll be 180. Okay. This is period 5. Lesson 6.3, number 16. All I have to do is read this problem to find out what term they want me to find, and use my formulas. Use a binomial theorem. All my pages fell apart. I did not have a good stapler in this thing. 14, 13, 16. There he is. He says, find the second term that means r equals 1 in the expanded form of 4x plus 1 to the 4th. So n is 4 from this number here. So in my calculator, I'm going to enter 4, choose 1, and I get 4 out. It's a second term. It's almost as easy to look at your, see this guy? He's the first term, second term right here. You see the coefficients 4? That's just as fast, isn't it? That's just fun to know. If you have a number that's not on a Pascal triangle, if you don't have your Pascal triangle, if you're doing your ACT and you have to find the fifth term of some polynomial to the eighth power or whatever, it's nice to know you can do this. Okay, now I take it times my first term to, I go 1 in, so that's to the third power, times my second term to the first power. So this is, remember I get my 3 times from 4 minus 1, n minus r. And then this is just r. So this is r and this is n minus r. This is n, this is r. How do I get r? I take 1 away from the position they asked me to find, because I start counting terms with the choosing 0. Now I get to do the math. 4 to the 4th power, 4 times 4 to the 3rd, 256. X to the 3rd, and 1 times that is that. You're done. How fast that went. Okay, I lost. Here's number 17. They want us to find the third term of this expanded binomial. R equals 2, n equals 5. Any questions on those? You get those two? You got the money. You want to use your calculator, fine. Otherwise, you count over 3 terms, see what the coefficient is. 5, choose 2. On the row 5, 1, 2, 3, I get 10. Calculator should tell you 10. And you take your first term. 5 minus 2 is 3. Your second term, R is 2. And do the math. 10 times 27 times a positive 16. 4320. X to the 3rd, y squared. Don't forget all those little details. Negative times negative is positive, right? So that's why I didn't have a negative in my answer. And if you're feeling the polynomial expansion, remember the first term is positive, the second term is negative, the third term is positive when you have a negative here. So we could just tell stories all day long. Notice patterns, makes our brains happy. Find the second term. Mine's not very challenging. That's okay. Hopefully your examples are. Oh, here's some big numbers though. 8x plus 5y to the 7th power. R is 1. N is 7. And you should know this. 7 choose 1 is 7. Like, I have 7 objects. How many ways can I pick 1 each? 7. I pick this A, B, C, D, E, or F, or whatever. And I take my 8x first to minus the 6th, and 5y is positive to the R, 1. So we get a big number. We're talking millions here, guys. 7 times 8 to the 6th times 5. 9,175,000. 40. So while you're doing your homework, x to the 6th, y, you need to write things down. I mean, how many ways can you do that wrong? Right. Have that calculator, calculator, calculator. You're done with your homework. Workday tomorrow as well. Questions on the math? Check for yourself. See if you know how to enter that into the calculator so it does it right. You don't want that to be your problem. That number should be the least of your concerns. The higher you go in math, the less numbers should be your issue. You know. Aren't you glad we have technology? You can practice your choosing. 7, choose 1. Tells the story. Isn't that a blessing? We'll shut off the video and guys engage in this great mountaintop of Module 6.